Hello everyone. Before we talk about the isomerism topic, I want to clarify some terms. First one is structural formula and second one is molecular formula. In structural formula, it is a more descriptive and in molecular formula, it is a condensed form. In molecular formula, only you can see that the which elements are there and how many are there. Let's look at the isomerism. The first one is CH3CH2COOH and CH3COCH3. The structure are not same, but their molecular formula is same. The first one is C3H6O and the second one is C3H6O. Like this compound say isomers. Their structures are different, but their molecular formula is same. So the first one is chain isomerism of pentane. Let's draw the structure of pentane. Then take one carbon, shift to at another carbon. Then it will form this structure. The molecular formula is C5H12 and first one also is same C5H12. Apart from this, there is one another will be formed, which when the right side chain of CH3 it come to its CH, it will form this structure. Its molecular formula will be same C5H12. The main side chain of carbon is 3 and the side chains are 2. It will also eat a C5H12. The second one is called 2-methyl butane and first one is pentane and the third one is 2,2 dimethyl propane. Let's pick one compound, this one. The methyl position will change to HCH2. The methyl position is shifted. There is nothing is going to change. Their molecular formula will be same, but their structure of name is 2-methyl butane. 2-methyl butane. It also be same, but there is no change in this shifting. So those are same. Now put methyl here and here like this. So both of them will be treated as a normal compound, just like the first one. So it is will be normal pentane, it will be normal pentane. So these two are will be same, so nothing is different. So there are only three possible chain isomers of pentane. First one is pentane, second one is 2-methyl butane, and third one is 2,2 dimethyl propane. In chain isomerism there is only change in carbon arrangement different and molecular formulas are same. Next one is position isomerism. Let's understand with these examples. So let's this alcohol shifted to this side. So it will form this. There is no difference in this. The only difference in functional group. So it is called position isomers. In this second example, they taken a double bond shifted to this side and it will form this. There is no change in this. The double bond was shifted. The carbon chain is still the same. It is. The carbon chain is still same and there is only changes in functional groups, double bond, triple bond, and their position is different. Let's talk about the metamerism topic. It is an ether and ketone. They have the side chain are same. They both side have a carbon chain, ketone and ether. Let's talk about the example of a ketone. Let's talk about this example. In this ketone, the two sides have a two carbons. Let's move this methyl carbon to this right side. It will form this. So now in this ketone, the left side is 1 and right side is 3. So now look at their molecular formula. The first one is C5H10O and second one also is H10O. So there is no change in carbon chain. And of ether and ketone, The secondary amine and thioether also shows the metamerism. Let's talk about the primary and secondary and tertiary amine. So we draw the primary amine, simple primary amine. So we know that the primary amine have a side chain, one carbon chain, and secondary amine is two carbon chain, and the tertiary amine is three carbon chains. Now let's make secondary amine out of it. Take one nitrogen and take two carbons of left side and one carbonate side chain. So this is the secondary amine of ours. So we have three carbons in secondary amine and three carbons in primary amine. So the carbons are balanced. So we have in secondary amine one nitrogen and primary amine we have one nitrogen. So we know that how to add hydrogen in carbons. So carbon around there are four. So carbon around is four bonds. For this carbon, we have one bond already. So left are three bonds. So we are adding three hydrogens in it. So it will form CH3. So second one is this carbon. We have in this carbon two bonds already. So two hydrogens already. So inserting we are adding H2. So it will form CH2. So in this third one is one carbon is already attached, so it will form CH3. So now the turn is about nitrogen. So nitrogen around it will form three bonds. So the one bond it with hydrogen. So it will form complete the secondary amine. So primary amine and secondary amine are done. So now the turn about tertiary amine. So in tertiary amine, the nitrogen around with three carbons. So these are the three carbon chain. In these three carbons, now complete the hydrogens. So the nitrogen already completed, so it will become the tertiary amine. In these three structures, total there are three carbons are there. So this is a C3. So in this all three amines, how many are hydrogens? So first one is 9 hydrogens and second one 9 hydrogen and third one also in 9 hydrogens. So it is H9. So how many nitrogens are there? There one. So C3H9N. So their molecular formula is C3H9N. So all are they are isomers. So these are the primary secondary